Assume that the function f of x is equal to the a x squared plus bx plus c, where a is different from 0, has two real zeros. Show that the x-coordinate of the vertex of the graph is the average of the zeros of the function f. First of all, uh, let's take a pen here and let's start. So average, we already know average is of the x's of the solution of the x is equal to x1 plus x2 divided by 2. So this is the average divided by 2. But we already know from the formula of quadratic equation, the solution that gives us the quadratic formula, the quadratic equation formula, is as follows: is a minus b plus minus square root of b squared minus 4ac. We already know this. Minus 4ac. So it means those are two solutions that we get from the quadratic formula over 2a. And now let's take this as a, let's say average, av. Let me write av here with the index, with the sub v. So maybe it looks better. And now x1 plus x2. So x1, let's take first the solution of the quadratic equation, which can be, let's say, is a plus. We can take either one, doesn't make any difference. B squared minus 4ac. B squared minus 4ac. 4ac. Everything divided by 2a. So this is a x1 2a. Plus, let's say x2 is equal with a minus b, the second solution, the second zero of the function, b squared minus 4ac. B squared minus 4ac divided by 2a. 2a, and everything here is divided by 2. Divided by 2. Let me take it this way. Divided by 2. So now, if I have this 4, now what I'm going to do here, first of all, let's see what we have at the same term. Because the LCD is a 2a, so we can simplify this term, plus b squared minus 4ac minus b squared minus 4ac, and we can add those b's with the same sign, and the average rate, the average of x1 and x2 is going to be equal with minus b is minus 2b divided by 2a. And now here, because it's a division and this is the first term I can write in the same way, and I want to convert this into multiplication, which is, I can take the second term as its reciprocal, so I am multiplying now by 1 over 2. But because here 2 and 2 we can simplify, and finally we can get here average of x1 and x2 of these two solution is going to be minus b times 1 is minus b over 2a. 2 times a is 2a. So in fact, this is the axis of symmetry. We already showed the x-coordinate of the vertex of the graph is the average of the zeros of the functions. So this one is equal with the axis of symmetry. So, and we already know the vertex is h times k, h comma k, This is the vertex, and the axis, this is equal with the axis of symmetry. So axis of symmetry is equal with the h, with the first coordinate of the vertex, and this is equal with the average of the two solutions of the quadratic equation. So we already proved.